Now we know trigonometric points for, pi over 6, pi over 4, pi over 3, and the compass points too. But I think we can maybe extend our understanding of trigonometric points into other quadrants as well. Okay, and so we're going to begin with this example and then sort of dissect what we do and to help us kind of generalize the process. Trigonometric point for p of 5 pi over 6. So I need to know what the coordinates are, right? I want to know what x, y are. I have the angle, okay? So first, I like a little sketch. So here's what I'm thinking. Okay, so we have unit circle. This is going to be an awesome circle. Actually, it's not bad for freehand. Okay, again, it's just a sketch. It doesn't need to be perfect. But I'm interested in 5 pi over 6. Okay, so this is an angle in quadrant 2. If you need to review your angles, please do. Okay, so here's 5 pi over 6. Okay, and I want to know what that point x, y is. Okay, so at first glance, I don't really know how to do this. It's kind of intimidating, but what I notice is that T, right? T is the arc length along here. So technically when I draw this, I'm saying that, T is 5 pi over 6 here, okay? And what I notice in addition is that if I were to go from the point to the x-axis, that is pi over 6, right? Well, wait, didn't we just discuss pi over 6 over here? So, okay, I'm going to draw this in purple. This is also pi over 6. Okay, and then here, I knew that this point, this trigonometric point, so this is also pi over 6. This trigonometric point was square root of 3 over 2, comma 1/2, right? I'll maybe zoom in on my picture so it's a little bit clearer. All right, so, I mean, so this is a distance of pi over 6 along the unit circle from the x-axis, right? Shouldn't we be able to do the same thing over here in quadrant 2? Maybe just reflect it over. So, I mean, change it into the appropriate quadrant? Well, yeah, actually. So if we imagine reflecting this given point or this special angle into quadrant 2, well, what changes, right? In quadrant 2, the x value is negative, so negative, and then the y value is positive, right? So this point, this xy point, would, if it reflects, again, it keeps the values, it just changes sign. So x is now negative square root of 3 over 2, and y is 1/2. Okay? And so all I did was use a little bit of geometry. So I recognize, yep, I'm given 5 pi over 6, and then the little bit from the trigonometric point to the x-axis along the unit circle there, that was just pi over 6 radians. Well, I had discussed pi over 6 radians in the first quadrant and said, okay, I know the trigonometric point for that. And so if I were to reflect that into the second quadrant, it keeps the values, just changes the signs as needed. Okay, so there we go. We found the trigonometric point for p of 5 pi over 6 is equal to negative square root of 3 over 2, comma 1/2. Okay, so now we have access to even more trigonometric points. Okay, now this work that we did, okay, there are some technical names for it. When we recognize that from our trigonometric point that we were interested in to the x-axis was pi over 6, that's what we call a reference number. Okay, it's another t value that is the shortest distance, or shortest arc length rather, from p of t to the x-axis. So this pi over 6 here was our reference number. Okay, and to go along with that, I have a habit of talking about reference angles instead. It's just my training that I've gone through. But the reference angle would be the angle that corresponds to the reference number. So right in here, this angle would also be pi over 6 because we're on the unit circle and t is equal to theta, right? But this here, let me draw that a little bit better. That would be our reference angle. Okay, and so the notation that we give these things, the reference number we would call T prime. Okay, and it's just a symbol to represent a different arc length that we're referring to. And similarly, since we're talking about a reference angle, angles we typically talk about as theta, we're just going to use theta prime to talk about a reference angle. Okay, so that was kind of the idea of reference numbers and angles. I guess we use reference numbers and angles to get our answer here. Okay, now our trigonometric point happened to be in quadrant 2. Okay, so when we look in quadrant 2, generally what we will see is that if we have a certain terminal side here, so this would be theta, right? And then this whole thing would be t, right? When we look in quadrant 2, this little bit here from I should label our trigonometric point there, okay? So the little bit in red along the unit circle, that's going to be our t prime, and then our angle that corresponds to it is going to be our theta prime, okay? What about the other quadrants? Okay, I want you to draw, or I'll draw a representative angle in each one. So let's see, in quadrant 1, we have something like that with trigonometric point there. Let's do something like this for quadrant 3, and quadrant 4, I'll do like that. My question is, can you identify t and theta as well as t prime and theta prime? Pause the video, try it out. And here you go. Quadrant 1, t and t prime actually end up being the same because, again, the definition, if you take a look at the definition at the top of the screen, it's the shortest arc length from your trigonometric point to the x-axis. Okay, x-axis, not y-axis, x-axis. Okay, so t and t prime are the same, as well as theta and theta prime in quadrant 1. Quadrant 2 we did. Quadrant 3, again, t would be the entire arc length from 1, 0 all the way around. Okay, and then t prime, again, is the shortest arc length to the x-axis. So there we go. And theta prime would be the corresponding angle. Quadrant 4, again, t would wrap all the way around. Theta would wrap around as well. T prime, again, to the x-axis, not to the y-axis. Okay, number one mistake that I see students make here is they say this is t prime here in purple. No, it has to be to the x-axis. All right, so that's the conceptual idea. Let's get some practice. There's a lot of examples here, okay, and there's a lot of examples for a reason, okay. I'll do a few of them, and then I'm going to just show you the answers, and you can do them on your own, okay. Let's do the first 3 together, say. Find the reference, we'll actually skip around. Just kidding. Okay, so 3 pi over 4. Okay, first thing I do is I sketch it. Okay, unit circle, 3 pi over 4, right over there, 3 pi over 4. Okay, this would be then pi over 4, and then again, since that is, so I'm saying theta prime is pi over 4, that also is t prime, right? Because we're on the unit circle, okay? So my reference number for each of these, I actually can't say equals. I'm just going to do like a little squiggle arrow and say that this is, that gives me t prime is pi over 4. Okay, let's skip to this one here. Okay, now this is in a different quadrant. Okay, so we're here. Okay, 4 pi over 3 would be all the way over here. Okay, so that, and then you can imagine this little terminal side here. Okay, this is 4 pi over 3, and then since we're in quadrant 3, this would be our t prime, and this, for me, it's always easier to think about the angle. The angle up to the x-axis is pi over 3, so that means that t prime is pi over 3. Okay, so t prime here is pi, not 4 pi, pi over 3. Okay. Next one, 11 pi over 6. So again, make a little sketch here, and I'm going to sketch 11 pi over 6. Its terminal side would be here, go all the way around to here. That's 11 pi over 6. And then again, from P of t to the x-axis, that would be our t prime. And here, I think about the angle. The angle here would be pi over 6. It's super tiny. Let me maybe zoom in. There's our t prime, or our theta prime, right? Theta prime, our reference angle is pi over 6, so that is the same as our t prime. Okay, so I'm just going to make note of that. T prime here is equal to pi over 6. Okay, so the others I want you to give a shot at, and when you're ready to see the solutions, resume the video. Here you go. That's a lot. So if you need to pause the video, take a look at it, I understand. There's a couple that I just want to emphasize, and they're the last two. Okay, so in the last two, we can have a negative arc length, right? That just means we go clockwise instead of counterclockwise. Well, so I went negative 3/4, ended in quadrant 3, and then again in here that would be the shortest arc to the x-axis, which is has a reference angle of pi over 4, meaning the reference number is pi over 4. The last one I really liked because you actually wrap around the circle twice. Oops. So you wrap around the circle twice for 13 pi over 3 and then go an additional pi over 3. So you can do this thing. All you're really looking for is a coterminal angle. And this one was coterminal with pi over 3. So then since the reference angle, since we landed in the first quadrant, our reference angle was the same as our coterminal angle of pi over 3. And that's why our reference number is pi over 3. Okay, so long video, I apologize, but we have to get a lot of different concepts in, okay? Why do we care? If you remember at the very beginning, we wanted to find more trigonometric points, okay? And actually, we can find many more trigonometric points now that we have reference numbers at our disposal, okay? So I'm going to show the trigonometric points that we already know on this circle. Here's what I have so far. So I have the compass points, okay, and notice I'm labeling this as 0 degrees, 0 radians, and then the point, okay? So you can see in each of these I have the degrees and radians labeled as well as the point, the trigonometric point that corresponds to it, okay? And now I'm color coding this because it all coordinates together. So for instance, the 30 or the 150 is in red because we found that the reference number for that angle was pi over 6, which was our red angle. And so now I can go ahead and say, okay, well, the reference number for 330 degrees, which is 11 pi over 6, is also pi over 6. So then I can use the coordinate that I got from pi over 6 and just translate it to the appropriate quadrant. So in quadrant 4, x is positive, so keep the x coordinate, and y is negative, so change it to the opposite sign. In the same fashion, we can look at 7 pi over 6 in quadrant 3, which is 210 degrees, and that again has reference number pi over 6. So again, just take the coordinate and translate it to the appropriate quadrant. So in quadrant 3, negative x, negative y. Okay. And now we can do the same thing with the 45. So this angle in quadrant 2, which is 135, also known as 3 pi over 4 radians, has reference number pi over 4. Okay, so then translate the coordinate to the appropriate quadrant. So negative square root of 2 over 2, comma, square root of 2 over 2. Okay, and I'm going to let you fill in both 225 and 315. There you go. And lastly would be the those angles that have a reference number of pi over 3, which would be 120 pi over, or 2 pi over 3, 240, which is 4 pi over 3, and 300, which is 5 pi over 3. And so these, again, since they're reference numbers all pi over 3, use the coordinate for pi over 3, just translating it to the appropriate quadrant, negative 1/2 square root of 3 over 2, for instance. And there you go. Okay, this is what I refer to as a completed unit circle, and it will be of extreme importance as we go forward. So make sure to get this in your notes. You might even want to print this out, get it on a separate page. If you Google like unit circle completed in Google, you'll get a different image there. So if you want to just access it that way, that's fine. But having a piece of paper for this might be super important. So we'll use this in an example coming up.